Okay, good afternoon or good evening, everyone. You're very welcome to tonight's lecture. It's been co-hosted by the Midlands region and the Public Service Division. And the title of the lecture is Energy Efficiency at Home. In case I forget to mention, the lecture itself is worth 1 hour of CPD, so please make sure that you log that after the lecture. And with all other lectures I'm sure you've participated in, you can pop in your questions in the Q&A function there at the bottom of the screen, and we'll take them at the end. Tonight's guest speaker is Mr. Pat Hunt. Pat is a Senior Assistant Chief Fire Officer with Westmeath County Council, an active member of Engineers Ireland Midlands region and the Public Service Division. He's a Chartered Engineer for over 20 years and a Fellow of Engineers Ireland since 2017. I'd now like to hand you over to Pat for tonight's lecture.
Thanks very much, John, and very good evening to you all. Special thanks to the Midlands region for the invitation to address you all tonight, and also to the Public Sector Division as well. Tonight's presentation is going to be looking at a rather holistic view of energy efficiency in the home, and my job over the next 35 minutes or so is to try and prevent you from all going asleep on me. So just to give you a quick disclaimer, first of all, that the views, thoughts, etc. that are expressed tonight are indeed my own. Not that anybody would have given me any credit for plagiarizing them off anybody else. But again, as I said, this is just a standard disclaimer for tonight. So the overview of tonight's talk is, first of all, we're going to look at the need for greener buildings. I think we're all familiar with that, but it'll just be a quick recap. I'll be discussing alternatives to conventional construction and developments in the timber frame construction sector. I'll be looking at issues surrounding home electrical generation, in particular focusing on photovoltaic panels or PV panels. I'll be looking at the growth in electric car technology and some issues that I think will form part of the Q&A, hopefully at the end of tonight's session. I will touch on lithium-ion batteries and why they are of concern to us all as the way forward, particularly so in relation to various incidents that have arisen with them. And now I'm just going to take you through to what's happening in the building methods within Ireland and internationally. Well, first of all, the reason why we're looking at the whole issue of efficiency and energy efficiency within our buildings is to deal with the whole issue surrounding climate adaptation. I think we're all familiar with that. It's been one of the highlighted topics in the United Nations General Assembly meeting this week, and has formed a major part of government policy here domestically as well as internationally. We need, of course, to reduce the overall carbon footprint of the economy and the domestic sector. And indeed, that is leading us to looking at new methods of building, new products for building, etc. The age-old problem of housing demand and the need for additional building stock. This is coupled with the need to improve existing buildings, and that formed the major announcement from the Department of Housing there recently in relation to the Housing for All strategy document. Again, we're all familiar with the fact that housing demand is at a peak here in Ireland, and not just within the Dublin region. But equally, if we look further beyond our own shores, this is a major issue internationally, as well as nationally here as well. And then finally, we have the issues around the circular construction and circular economy cycle. And I don't know if any of you or most of you are aware of this, but I will just basically recap on this. Moving back to government policy and indeed the direction that the government and indeed the industry are heading towards, the Irish government produced a very, very ambitious document back in 2011, which is the Climate Action and Low Carbon Development Bill, which is a unique document in the sense that it transposes aspirational goals into legislation and commits Ireland to achieving net zero emissions by 2050 and securing a rather ambitious target of 51% reduction in emissions by 2030. Now, you realize the scale of that ambition when you realize that we are almost 3/4 of the way through 2021. That means we have approximately 8 years and 3 months to go to meet that target. So as I said, it is ambitious. The action to achieve this, of course, as everybody knows, will see, first of all, an increased electrification of both the heat and transport section. We'll be looking at improving energy efficiency within buildings, reducing emissions from agriculture, and developing clean public transport. Now, while I won't bore you with item number 3, the reducing emissions from agriculture, because clearly I have very, very limited expertise in that, tonight's talk will be looking at various issues around item 1 and item 2. I think I'll leave the discussion around cleaner public transport for those that are more qualified in the area of transportation. If we look here to the right, I'm sure everybody has seen this statement here, the 17 sustainable goals that have been produced by the United Nations. And that again forms the keynote to, or provides the cornerstone to this particular document. As I said initially on the third slide or so, the whole issue behind the circular economy is where, and circular construction, and the circular construction section is where we're going to go, whether we like it or not. This is a case where it'll cause us as engineers to rethink what materials we will be using within the various structures that we actually design and ultimately build. To recap, a circular building are buildings that are designed, planned, built, operated, maintained, and deconstructed in a manner consistent with circular economy principles. And there's a very, very good article there from the Irish Building Magazine in 2020 outlining how, by embracing this circular economy model, can add value to the Irish construction sector. But we're all very, very familiar with the production cycle. And I'm just going to talk about this very, very generally. We all start off with raw materials, which go into a production plant, ultimately leading to the product being ready for distribution and sale. The product is then taken and installed. It goes through its design life, and it's maintained during that design period. So we're familiar with that green path. Now, this is the path that's relatively new, or I think it is, in the sense that after the maintenance period, in other words, once you've got to a stage where the product is met its end of life or can no longer be economically sustained, or there's a change of use in the building in which it was installed, which renders it, I won't say unfit for purpose, but certainly not desirable, then you have to go through the process of installation and removal. And yes, we're all familiar with that, and the disassembly line. But this is where it becomes relatively new, in the sense that you're looking at using materials that can now be, first of all, maintained, removed, disassembled, and recycled. And this is I think, the most challenging part of this particular model. In other words, how do we actually design products for use that are serviceable in the sense that they are easy to use, easy to maintain, but also easy to remove, disassemble, and then reincorporate back into the in-use cycle. As engineers, this is going to present us with significant challenges. And as I said at the very, very start, we're familiar with the fact that we have a major housing problem, or a major housing crisis in terms of supply, but equally as well in terms of retrofit. How do we make sure that the products that we put into retrofit a house to improve its energy efficiency can slot into this particular cycle? Hopefully I'm not losing anybody so far. So next thing we're going to look at is the move to use timber in building construction. And this is brought about by a number of factors, one of them being the fact that timber sequesters or absorbs carbon during its growth process. Anybody that has done science for the intercert will be familiar with the process of photosynthesis, where a plant takes in carbon dioxide from the atmosphere, converts that carbon dioxide into carbohydrate or sugar, and then releases oxygen as the byproduct of that reaction. So in other words, a plant as it grows takes carbon dioxide, removes it from the environment, and releases oxygen to the atmosphere. And this is why timber is increasingly popular, because it's seen to be a green source of material. The manufacturing process for timber is often thought to be lower in energy and less carbon intensive than its alternatives, whether those be steel or concrete. Timber structures themselves are extremely lightweight by comparison, and the construction with timber is often quicker and cleaner, hence less time on site. And there is also a current trend for architectural desires for exposed timbers for well-being aesthetic purposes. Anybody that has been to or read any of the House and Magazine type articles, the Scandi look is in. A number of years ago, it was launched onto the market, and it's that the kind of trend hasn't left for this exposed timber. One thing that, of course, as engineers in Ireland, we're all familiar with is the fact that timber is all fine and dandy, except that we have issues here with dampness. Now, one could argue that, yes, we do have a damp environment, but if you look at our Scandinavian countries, they have similar levels of dampness. They have high thermal gradients throughout the year, and they successfully build in timber. So the question we have to ask ourselves is if it's been, how you say, embraced internationally, why in Ireland should we be any different? And the last thing is, as I said to you about the circular economy, is the fact that timber is demountable and maybe, depending on the type of treatment it has been subjected to at the time of its manufacture, recycled at the end of its life. So, as I said, this is the traditional, or not the traditional, this is the current trend where you have your kitchen island, you have your dining bench, exposed timber. If you look to the roof elements here, you have exposed board, integrated appliances, and generally this is the aesthetic which is currently in vogue at the moment. Now, just to recap on the two different types of timber in construction, first of all, we have the larger scale size of timber, which you can see are broken down into two different types. These are basically mass timber for non-domestic buildings. The first one I think that everybody is coming to terms with is what's known as cross-laminated timber, where timber lats are laid at right angles to each other and glued. So in other words, you have a timber in one direction, a timber at 90 degrees, another timber at 90 degrees, and so on, where you have a beam or column element built up of strands of fibers moving at 90 degrees to each other, or rather orientated rather than moving at 90 degrees to each other. And these tracks or sheets of timber are held by some sort of glue or resin product. And then you have what we are all familiar with, I think, in various buildings in Ireland, is the glue laminated timber, where you have boards or pieces of timber that are built up to provide a column or beam element, but they are where all the strands of timber or all the grains of timber are traveling in the one direction. Now, if you remember your first or second year mechanics and materials from college, you'll appreciate that if a beam deflects like that and all the fibers are running in one direction, if you apply a load, there's going to be greater deflection on the center if you have a simply supported structure. However, if you have a cross-laminated timber, you have less of deflection because the fibers are running at right angles to each other. So they're very, very good for large spans, large clear spans, where you want to minimize the deflection in terms of ultimate limit state and serviceability limit state requirements. And this is a photograph that was taken by Pat on his holidays about 2 months ago. I was in France for a couple of days, and you can see this is a temporary building that has been constructed to allow the refurbishment of the Grand Palais in Paris. As you can see in the background here, you have the Eiffel Tower, and here to the foreground, you have the Champ de Mars, and leading to the Arc de Triomphe and Musée d'Homme. But as you can see here, this is a very, very interesting use of glue laminated timber. You can see here how easily it's molded into a form to provide an elliptical arch with elements here providing structural truss details bolted on to, as you can see, probably not here, but you can actually see there is actually a concrete foundation here to support the overall mechanical load of the building. The one thing you have to realize about these kind of structures, whether they be glue laminated or cross-laminated timber, is the fact that if they're being constructed, they're constructed on a robust concrete foundation with usually the first floor of the building. If you're looking at something that is, say, 3 or 4 stories high, you're looking at the first floor being a concrete structure. In other words, you're providing a concrete box, which is going to provide the podium level on which you construct your subsequent floors. So again, you must realize that the building isn't just a case of a timber building dropped onto a concrete found. It's a case of, to give the building structural rigidity, you have a concrete floor to act as your podium level to enable your construction heading up. So now moving from the kind of upper end, the mass timber element, we're moving into what we're all familiar with, the timber frame construction within the domestic sector, where we're looking at the use of OSB boards. It has become an increasingly popular build route, and timber frame is the method of choice because you can assemble a lot of the units off-site and then move them onto site via a low loader or another means of transport and assemble it quite quickly. As I said, the most common construction method involves layering with boards, usually OSB boards, oriented strand boards, and just specifying high levels of insulation and air tightness. Again, looking at the whole issue surrounding climate, energy efficiency, and reducing the carbon footprint. The timber frame, by its nature, because it is a frame, it allows you to incorporate a number of different elements in relation to the design. And this is why timber, again, and timber frame in the domestic sector is very, very popular, because it allows designers and it allows the client to customize their home in a particular way in relation to how much or how little they want to spend on the structure. As I said, timber frame is often used as a structure on which to layer other eco-build materials. These most recent ones I've seen used are straw bales, hempcrete, which is a traditional, almost like the old medieval wattle and daub type finish, where you're applying a lime and a hemp mix to provide an insulation type material. And then you have and again, going back to medieval times, a rammed earth solution. Now, before we kicked off the discussion tonight, we were just talking about this, and I raised the point that there's a very, very good video from United Laboratories, looking at flammability rates within natural materials and synthetic materials. And if you ever had a doubt of which would be better in terms, and I'm speaking here with my fire helmet on, if it's a case of you're looking at a comparative study between synthetic versus natural materials, this video will certainly push you to the use of naturally based materials rather than synthetic. And the reason for that is the synthetic materials, and this is a kind of a universal truth, that if you use synthetic materials, the heat release from the product is enormous. Equally, the rate of fire growth is significant. Whereas if you use products that are primarily organic or naturally based eco materials, the thermal reaction and thermal release rate is much, much slower, and the overall fire growth rate is much, much less. So that's an aside as we move on. This is when it goes horribly wrong. This is taken from fire in the Netherlands, in Hertogstad, where, as normal, fire occurred in the early hours of the morning around 3 a.m. And as you can see, unfortunately, the one thing about timber frame in relation to fire, it doesn't hold particularly well. In fact, you can almost say that with certainty that timber frame, if it's involved in a fire, the destruction will always, most of the time, should I say, be total in comparison to conventional, traditional construction. Earlier on this year, I attended the Fire and Safety Division's seminar, and our colleagues in OVR presented this very, very good graphic at the time, looking at how we examine design in relation to low-rise, medium-rise, and high-rise buildings. And they said that the design approach is risk-based and evidence-led, and I don't think anybody here tonight would disagree with that. But looking at the low-rise first, which would be your domestic construction, we would hope that you would have an evacuation period that would be relatively fast. that, of course, if we were fighting a fire, we would assume that everybody would be out and that you would fight the fire externally. The consequences of failure would be low, with complete loss would be acceptable. That the load-bearing elements, of course, would have this quite a low fire resistance, so hence tolerable collapse. And for separating elements, that you would think that, you know, fire spread would be tolerable. And on the face of this, when I saw it initially, I thought, this is a very, very good slide, and it encapsulates more or less most of the design philosophies that are out there. And again, a very much broadly accepted design approach. Until I remembered this. This is the Millfield fire in Millfield Manor in Newbridge, County Kildare, which occurred in 2015. To give you a little bit of context, the blaze spread across 6 houses in 25 minutes. Nobody was hurt in the incident. The fire was an arson fire, believe it or believe not, set by an aggrieved individual. I won't go into the motives, but all I can tell you is that the seat of the fire was here, and it was deliberate. The fire spread was helped by poor workmanship and improper joining of plasterboard to the separating walls in the attic spaces. So it was an issue around fire stopping and compartmentation. So just giving you another picture of that, that's the destruction in 25 minutes. Now this occurred at, I think, 9:25 or between 9:30 and 10:30 on a weekday morning, right? Now, can you imagine if this was the same scenario, that fire was deliberately set at 2 a.m. or 3 a.m. in the morning, or indeed, if it wasn't a deliberate fire, that it was an accidental fire where somebody came in from a good night out and has happened, decided to cook themselves some sausages or whatever to absorb the alcohol that's taken the night before or the evening before, and the kitchen took off. But look at the damage that you see. The roof is completely gone. The seat of the fire the damage is total. But bearing in mind, these are 6 houses, and assuming, of course, that there are 4 people per houses, that'd be 24 people that may or may not have been killed or seriously injured as a result of that single fire. Again, it's a sobering thought. So going back to our friends in OVR slide, as engineers, and particularly the engineers and the audience that are working in housing and indeed in the local authority sector, or indeed in the private sector, now if we're looking at the top line or in kind of keeping with the demand for housing, the fact that the housing market is so aggressive and there is such a need, that, okay, fair enough, in a low rise, the fighting methods and the evacuation, I'm not going to deal on that, but the consequence of failure is low and complete loss is acceptable. Now, speaking with my local authority hat on, if you have 6 families made homeless as a result of one single fire in 25 minutes, can you consider that consequence of failure to be low? Secondly, you have to ask yourself is, can you say that the financial loss of that asset, say for example, it was a local authority housing scheme, can you say that the loss of that asset is acceptable now that you have 24 people added to your housing list and that are now homeless? And in terms of the fire spread, can you say that in that particular instance, that the fire spread in that particular instance was tolerable? And honestly, as a professional working in the fire sector, I can say, well, fire spread in that instance is definitely not tolerable. In fact, there was no attempt, or so it seems, for the construction, that the fire was actually contained. But this is the one I want to kind of stir your conscience with. Now that the buildings have failed, all 6 of them are gone, can we, as engineers who are dealing with housing crisis, for want of a better word, can we say that that level of losses is acceptable? And particularly for us here in the Midlands, who are dealing with rural communities or indeed smaller urban communities, can you imagine that kind of load on your housing sector and indeed in your housing offices on a daily basis? I shudder to think of it. And this is coming from somebody who worked in housing and had to deal with people who were homeless, etc., or on the housing list looking for a suitable accommodation. So moving on to the issue of lithium-ion batteries, as I said, this is a very, very holistic kind of 360-degree view of energy efficiency and some of the pitfalls of it. And what I'm trying to do tonight is not to be provocative, but certainly to promote a certain degree of discussion and get people thinking about what they're designing, how they're designing, and indeed the inherent risks that those designs may have. Maybe not today, as Frankie Byrne used to say years ago, maybe not today, maybe not tomorrow, but soon. But first of all, let me go back to the topic at hand, and that is the introduction to lithium-ion batteries. The lithium-ion battery industry is massive. It's a growing market, and it's a growing market internationally. As you can see in the area of transportation, we have lithium-ion batteries in cars, buses, forklifts, and auto bicycles, scooters, etc. The consumer electronic devices is huge. For example, smartphones, laptops, tablets, power tools, personal cares, your shaver, your brawn toothbrush, etc. But also as well in the grid energy sector, in stationary energy storage, the grid energy, the renewable energy sector, which we're going to talk about shortly, and the portable energy storage system as well. So moving on there, as I said, lithium-ion batteries are rechargeable and used worldwide. Common applications that use lithium-ion technology include laptops, mobile phones, electric vehicles, and electric storage systems. I've already covered that in that graphic. And the reason they're very, very popular is because they produce a high energy density and can be recharged time after time. And that's the beauty of them, the fact that they are rechargeable and they hold their charge extremely well. Moving on to our PV panel systems, I think we're all familiar with the concept. PV panels on your roof facing on a southerly direction, leading to power optimizers and a battery pack, which in turn feed into an inverter, which converts the DC electric current produced into an AC, which in turn can be used to power up your domestic appliances or heat water, etc. And then anything the surplus can be, depending on the amount produced, go into the national grid. As I said, the PV panel system are very, very straightforward. As I said, solar panels where the sunlight shines on the roof, providing the DC electricity. The bracket system, of course, supporting the panels onto the roof. The inverter, which uses technology to convert or transform the power from DC to AC, so it can be used to power the home. The electricity itself, then produced and consumed on the domestic premises. The diverter unit, which allows feeding into the grid. And here in red, what people don't realize, the use of a lithium-ion battery, which stores the free electricity generated during the day so that it can be used to power the home at night or on cloudy days. And this is the reason why I wanted to introduce you to the issues around lithium-ion batteries. We're all familiar with them. We know that they're out there because we use them every day and we don't think about it. I'm actually using one right now on the laptop and I have my mobile phone here beside me, both powered by lithium-ion. But here's the rub. Lithium-ion batteries themselves are capable of spontaneous ignition and subsequent explosion. And these conditions that lead to the spontaneous ignition and subsequent explosion are called abuse conditions. Abuse conditions can be caused by a number of factors, one being overheating, two being rapid discharge, or electrical shorting. Overcharging of the batteries again, and I think most of us are familiar with that we charge a particular device, whether it be a tablet or a laptop or even a shaver or electric toothbrush, can find that there is a residual amount of heat when you touch it. What is more disturbing is the fact that you may have abuse conditions caused by poor defects or poor designs of the batteries where they're not adequately ventilated. This is particularly true in relation to laptops where for example, the ventilation isn't very, very good around them or it hasn't been designed properly, and you in turn leave it on a desk or in indirect sunlight, or there's no ventilation in the area, which in turn leads to the device overheating. And the last one, of course, is mechanical damage, which naturally enough, if you damage the battery, like any battery, whether it be your traditional 12, 24 volt battery, if you drop it and damage it, the electrolyte leaks out and you damage the actual cells inside. It's absolutely no difference for the lithium-ion situation. The problem with the lithium-ion batteries, unlike your traditional car battery, where you would have a leak of acid and so on, is that if you damage a lithium-ion battery, you have what's known as a thermal runaway condition, where you have a spontaneous ignition and a spontaneous ignition and a subsequent explosion. And the thing about it is you will not get a warning about these. The gas release rate is quite rapid, and it'll go from being looking relatively inert and innocuous to a full-scale on-fire situation very, very quickly. That's the reason why, if you're ever on board any aircraft, the air stewards always warn you, should your battery come detached, or should you lose your mobile phone, or should it get hidden behind a seat, to tell them immediately, because they're terrified that if you have a fire at 33,000 feet, that it could become a particularly serious and potentially life-threatening situation. As I said, the overheating in the lithium-ion batteries lead to what's known as thermal runaway reaction, which is the reaction within the battery causing the internal temperature and the pressure to rise at a quicker rate than it can be dissipated. And that's the mechanics of any explosion. But bearing in mind these batteries are now omnipresent and they're everywhere, you can see that it's a very, very, very short path to fire and explosion, where you have an internal degradation leading to a breakdown of the electrolyte, leading to internal damage, leading to fire and explosion. And the worst thing about a thermal runaway reaction, or indeed a fire with a lithium-ion battery, is this: the fire may be containable, but it's not easily extinguishable. There was a recent fire in a data center in Belgium, and you can get this fire on YouTube, where, if you can imagine a data center with battery storage half the size of your standard road container, caught fire. Again, thermal runaway condition. The fire service in question threw water on that fire for 36 hours, and that was the only way. The only thing they could do was cool it. They could stop it spreading, they could cool the immediate area, but they couldn't put out the fire, because this is an exothermic reaction. So the temperatures, it's a self-sustaining reaction. The temperatures are constant, so you basically have to let it burn out. Now, the problem is, if you're dealing with any of these in terms of a fire situation, what ends up happening is the more water you put on it, the more harmful materials you're actually introducing into the surface water runoff. And this creates an environmental risk, because you're dealing with lithium, which is the lightest metal on the periodic table, but also as well, you are producing byproducts which are pollutants. Looking at our friendly electric vehicle, you can see here that this is a very, very simplistic schematic, but you have a battery backup in the rear to supplement your fuel tank, and you have a dual motor system here, which allows for a measure of which that the electric motor can take over from the conventional motor. Again, these are powered primarily by lithium-ion batteries. And just going through the science a little bit, if you're to burn a car, it produces what's known as, from design purposes, a 5 megawatt fire. And that's comparable to your standard fossil fuel vehicle, whether you drive petrol or whether you drive diesel. The problem is that it's not a traditional 5 megawatt fire. A 5 megawatt fire in a conventional car fire, whether it be petrol or diesel, is relatively easy to extinguish. If you have a lithium-ion battery, as we saw 2 slides ago, involved in a fire, involved in something that leads to an abuse condition, you end up with this process of having a thermal runaway, where you have now got an exothermic reaction. In other words, a fire that is self-sustaining, and the difficulty is in extinguishing that. Equally, as well, as you saw from the schematic of the car, you can see that the fuel tank is close to the batteries. And the issue is that it's because you have such, usually the batteries are on the chassis floor, very, very close to it. It means that they're effectively insulated for a large degree from damage. But equally as well, if a fire, or if there's any sort of abuse condition going into the battery itself, then you're in serious, serious trouble. If you ever deal with an electric vehicle fire, the problem is that you need a large amount of water to cool the area. And I'm currently working with colleagues in various fire services in Belgium, Denmark, and Germany, and Spain. And their reaction is quite simply this: it's a case of if it's not a risk to anybody and the vehicle is already in the hard shoulder, you just let it burn completely, because the converse to this is if you start putting water on it, it's effectively you're just putting water on it to cool it, to cool it, to cool it. The water is being contaminated and you need a large quantity of water, so it's consuming a valuable resource. It's producing an environmental hazard, and equally as well, it's a case of you're going to be there a long, long time putting a lot of water on it, which is what is essentially an exothermic reaction. So in other words, you're on a hiding to nowhere. If you think that people haven't cottoned on to this, they have. This is an article from the Irish Times from the 18th of August this year, where it's titled by Neil Briscoe, where it says, "Something is burning, how serious are vehicle risks?" And the switch to battery bringing new challenges for dealing with car fires. And it's something that isn't actively promoted out there, in the sense that, yes, it's green. Yes, it produces less waste, it produces less carbon, etc. It's an environmentally friendly vehicle, but there is an inherent hazard with it. And this is proof from the United States that it does happen. So a scenario here that I just want to kind of discuss with you all is that we have a timber framed house with a PV panel on our south facing roof. And we just have to coming back from the game of golf, pitch and putt, whatever club you're affiliated to, and you charge your electric vehicle or your hybrid vehicle from your domestic charger outlet. Can you see the potential hazards here over what we have been dealing with in terms of conventional construction in the recent past? Like, you have a timber framed house with a PV panel, with an electric vehicle. So excluding the domestic setup and the amount of lithium ions that you would have in the house, on your laptop, on your other smaller devices, you will have a fairly substantial lithium-ion battery here on the PV panel. You will have a sufficient or a significant lithium-ion battery here in your vehicle. And the question you have to ask yourself is, I'm sure if you have an electric vehicle, like all cars, you'll have them serviced and tested on a regular basis. But if you're installing a PV system, how often is that being maintained and inspected? And how regularly is the battery, the lithium-ion battery that is part of the actual setup, being investigated, looked at, serviced, monitored, etc.? And rest assured, I can honestly say, hand on heart, that if you're driving an electric vehicle, you can be sure that that gets more attention than what's in here. So the question as engineers we have to ask ourselves is, should we be doing something, and should we be looking at this, which is a substantial asset? Fair enough, cars come, cars go, and you'll kind of reminisce about a car that you used to drive, but a home is an entirely different matter. We're coming to the end of the talk, and I just want to bring in one additional hazard that nobody has mentioned. This clip is taken from the Irish Times in August of this year, where it shows the greying of the Irish population, or projected greying of the Irish population over the next number of years up to 2050. And as you can see, they project that the population over 65 will go from a percentage of 14.4% in 2020 all the way up to almost 25% by 2050. So bearing this in mind, and bearing in mind that we are getting older, but we're also as well living longer, but we're also living longer with significant issues surrounding perhaps obesity, diabetes, or other mobility issues, which will give rise, and how should I say it, a move from your hybrid vehicle to something like this, where a mobility scooter. And the question you have to ask yourself is, how are these mobility scooters powered, and how are these actually charged? And then, unlike your electric vehicle, how often are these serviced, maintained, or deemed fit for purpose? And again, these will be naturally enough, they won't be parked in the garage, they'll be parked in the front hall, or close to the front door, or close to the back door, wherever it's easy for you or your significant other to get on or get off from. But my point is this, that if you have a significant unit of these powered by a significant lithium-ion source and something happens, the fire, as I mentioned a moment ago, will be significant, and the potential loss of property and, more importantly, loss of life will be equally significant. So everybody, to conclude, and hopefully I haven't bored you all to tears, we must realize that we're living in a constantly changing commercial environment with new products and new technologies, and that's a universal truth. It was true 50 years ago, 20 years ago, and it's true today. But unlike recent years, there is now increasing legislative requirements and national and international climate targets to be reached and achieved. And these are ambitious targets, both domestically and internationally. As engineers, we are duty bound to consider the hazards and associated risks in building new builds, but also in renovating and retrospectively dealing with an existing housing stock. One thing that we have to realize is that if we are putting products into new builds or indeed into retrofitting, we have to remember that the technologies themselves will change, and indeed the technologies incorporated into the building during its lifespan will change. But the building and the building structure and the building footprint and indeed a skeleton will endure. The point I was making before we kicked off this is the fact that yes, there is a rush to use ready-made products because they're handy, convenient, and available. But bearing in mind the particular risk, and I am speaking here with the fire officer's hat on, bearing in mind the risks in incorporating what I would call non-organic materials, petroleum-based, oil-based insulation products or assemblies, the potential loss to property and potential loss to life due to the thermal and the heat release and the heat release and the fire rate that can result in a fire is significant. And I think it's a case that we as engineers involved in either the building for the domestic sector or the institutional sector should be aware of this, conscious of this, but also as well consider other alternatives that may be out there, because as I said, depending on the profile risk and the end user risk, the hazards that you're putting in relation to, say, for example, a vulnerable community or whatever, could be significant. And if things go wrong, and we all know they do, Grenfell Tower is an example of that, it can show that something significant can occur in a very, very short period of time, but the reputational damage and the loss of life is something that is very, very hard to put behind you. So on that rather somber note, I'll thank you all for your attention, and hopefully none of you fell asleep. And any questions or answers, as Maureen and John said at the very, very start of tonight's presentation, should be in the chat box or Q&A box or whatever the case may be. And I'll stop talking and let John back into the show. So thank you all again. Thanks to both regions, and the region rather, and the division. And I trust that you all found that, if not interesting, at least thought-provoking.
Thank you very much, Pat. That was a very unique, interesting, and often sobering take on modern building techniques and equipment. I suppose only someone like yourself with such a broad engineering knowledge could deliver such a lecture like that. So thank you very much for that, and very well done. You might be getting away lightly on the old question front tonight. I'll just take a look at what's there, and we can discuss it. Usually when I say that, they come rumbling in. The first is, it seems like more of a comment than a question, but I'll pose the comment to you. It reverts around the Great Fire of Chicago in 1871. And I guess the question revolves around density, you know, with the increasing requirement for the density of properties. I suppose that poses an increased risk for fire spread, notwithstanding terraced houses, you know, the fact that they're so close together. Would you agree with that, Pat? Would that be a fair comment?
It is. It is a very, very good comment, John. And yes, there is a move towards, as you said yourself a moment ago, increased densification and an increased move towards high rise as well. So we're going to see greater density and development of brownfield sites, but we're also going to see greater height as well. Now, excluding the whole kind of, and I'll remove the fire officer's hat here for a moment in terms of active firefighting. We won't even go there. But if you have an increased density and you have a higher structure, if you have an incident like a mini Grenfell, for example, which would be an extreme example, but what's going to end up happening is, depending on, first of all, if you look at it, John, you remember yourself from looking at design of buildings in college, you'll appreciate that depending on how you actually design the building and airflow patterns, you will end up with vortices in the building itself. So you'll have basically little whirlwinds in or around the building, which it doesn't make it exactly desirable for the end user to experience. But equally as well, because of densification and high rise, what ends up happening is that if you do have a particular innocuous fire, for example, if you have underground car parking, for example, in a multi-story building, and that is not a kind of a crazy thought, what's end up happening is you have a very, very involved fire in a very, very confined space. That smoke has to go somewhere. So it can be funneled up depending on the density and the height of the building, and you could end up with a large release of smoke into the ambient environment over upper floors. And then that begs the question then, depending on how hot the smoke is and as I said, the level of byproducts that be contained from synthetic substances, how dangerous an atmosphere you're creating. So just looking at from that aspect of it, yeah, that is dangerous. But I think that COVID has caused a major rethink in how buildings are designed and in terms of densification. While there's been a push for brownfield sites to be developed higher and greater density, COVID has shown us that people can survive in small box-like apartments or in small units. But based on what we see as a result of COVID, if you're living in a kind of a box-like environment or confined therein for a substantial period of time, it isn't the most desirable way to live. And more so if you have small children. Like, how are you supposed to, as lockdown showed us, homeschool, or if you have toddlers, how are you supposed to deal with them, exercise them, give them fresh air, have an environment where yourself as a parent, you can just get out the door and, even if it's going to the shops, you can kind of, won't say leave the kids unattended, but certainly you can take them with you and keep them amused, or alternatively ask your partner to look after them, etc. It has really caused a radical rethink about how we live, and is it a case that we want to keep promoting this high density box-like environment as a suitable solution to the housing problem, or should we be looking at something that is far better than that, where we're looking at the Scandinavian model, where we're providing something that has a minimum space with a minimum amount of living area, and you have a design that is more, how we say, family friendly. It's going to be driven by two fronts, but I think that it's going to be driven by legislative demand, but it's also going to be led and driven by the building sector. In other words, what they're willing to build and how high they're going to build, and so on. It's definitely going to be industry led, and it's going to be market driven. It's going to be a very, very difficult one to solve, and it's something I think that will be revisited as time goes on. If COVID has taught us nothing, definitely people do not want to live like that anymore.
Okay. There's a question here from Mark, again going back to Newbridge actually. Would better checks on building quality adequately reduce the risk of the problem occurring again? And what materials were actually used to rebuild at the site? I'm not sure if you can answer that.
I can't answer the latter because I honestly don't know. Yeah. But I will say that yes, if there was sufficient compartmentation measures carried up to the underside of the roof, and that's traditionally, if you I would, I would challenge anybody to go, if they're living in a semi-D or in a terrace, to go up into the attic and say that they wouldn't be able to kind of move a partition board or whatever between you and the neighboring property. But the point is this: yes, the case in in Kildare clearly indicated the importance of making sure that you have vertical separation, and that it was the reason I put it up as a slide is to promote this kind of discussion, to show that if you don't have adequate vertical separation between properties and between dwellings, you will lose the entire terrace, or you will lose the adjacent property, because the fire spread, there is nothing there to stop it once it gets into the attic space. And the destruction, as I said, in the Kildare case, was total. And it's an extreme example, but the best learning tools are always the extreme ones.
Okay. There's a question here from Sinead. Beyond construction, whose responsibility will be to educate the new homeowners on their new, more energy efficiency home? Part L, energy rated home.
That's a very, very good question. And the answer to that is it falls on so many shoulders, and yet there's nobody uniquely responsible for it. Like, there is an onus on the builder. There is also an onus on the homeowner themselves to educate themselves. There is also the involvement of SEAI in relation to this. There's a whole raft of people that are involved in this. But the thing about it is, while everybody is a stakeholder in this particular space, nobody is actually taking the lead on this. And it's a very, very good question. And it's something that should be mooted. As professionals, we're playing in this space, and it's ultimately, it'll fall on us as designers and certifiers. So it's a case of, yeah, there is a need, but who will actually drive and pull all the stakeholders together to say, okay, this is the person that's going to, or this is the body that's going to be the lead on this. At the moment, it's a very, very gray area, and there's no clear leadership or direction on this.
Yeah, I'm always struck myself, but the effort that goes into, the certification of new builds, whether they be multi-unit or domestic units. But once homeowners put additional equipment into their houses, that's the end of the checking.
Yeah, exactly.
There is no state responsibility, other than if it's a rental property or a multi-unit property, to inspect those properties. And so there is a gap there. I think you're right, Pat. It's definitely an area for discussion. Next question, I suppose it sounds like a very electrical engineering question, but maybe solid state batteries, are they likely to replace lithium-ion batteries?
I don't honestly think that is the case. There's been developments in the whole kind of battery sector, and it's been driven by the fact that lithium is a resource. There is an issue with the thermal runaway issue. I know that there's been increased use, particularly in larger scale developments for energy generation, on vanadium batteries as an alternative to lithium ion. Vanadium, again, is a very, very good product. It's a much, much safer product than using lithium ion. But the reason why vanadium the take up on vanadium has been slower than lithium ion is because of the cost of vanadium, the essential raw material. So again, as I said a moment ago, in relation to looking at high rises and so on and high density, it's going to be industry led. Similarly, the materials and the type of batteries that are going to be replacing lithium ion is going to be, again, industry led. It's going to be very much a case of car manufacturers, for example, will want to make lighter vehicles. So they'll be looking at technology that will allow them to make slimmer batteries, lighter batteries, but at the same time able to hold and deliver power at a higher level, at a higher threshold than is currently the case.
Very good. And you've actually answered question here from Jared on any view of the safety of future battery technology. So you've
it's a case of it's an emerging technology. The battery technology has been there since remember when we were doing science back in the day, John. It was a case of we're discussing simple sync batteries and running in experiments with different electrolytes, etc., etc. And the technology behind batteries is as old as the Middle Ages. But I digress. It's a case of supply and demand. It's a case of the industry are looking for, and this is an international industry, where people are looking for more ways to generate power, firstly, But secondly, they're looking at ways to store that generated power. We had an example today where there was a widespread coverage about Irish wind energy generation, and what issues can we as a nation look to in the coming years, and whether or not we can use wind energy generation solely to satisfy energy demands. And if it's a case that you have energy and you have turbines being turned, yes, that's fine, you're generating energy, but how are you going to A, store that, and B, how are you going to safely distribute that within the national grid? So it's a case of, it's something that is emerging, but it's not just us. There are bigger players involved in this. I know the Chinese, the Germans, the Americans have significant investment in this because they realize the value of it, that they need to get themselves out of the carbon sink that they're finding themselves in, and they need to actually develop products that are more environmentally friendly.
And the final question here, or final unless someone else gets another one in, my friend and yours, Andrew O'Malan, the chair of the Public Service Division, who says he lives in a timber frame house, drives a battery electric vehicle. I can only park my car 3 meters from my house when charging. Is there useful fire detection I can use in case of a fire near my house?
Answer to that, Andrew, is, again, this is me putting my fire officer's hat on. It's a case of there's damn all you can do other than have your usual smoke detectors within the property to detect the fire itself. If it's a case that you're concerned with it, you can buy a very, very high-tech CCTV system that would actually zoom out onto the car itself and have some sort of thermal sensor on it. But that would be, you're talking megabucks for that. Again, if you're in the house and the vehicle is 3 meters away, trust me, given the rate of reaction, the heat that is generated, let me assure you that if you have a car and you have a car fire and it's parked on your front drive and the fire takes off, it will probably melt the surrounds to your double or triple glazed windows. It will definitely melt your eaves and guttering if they're made of any sort of plastic or composite material. And as a result, based on that, it will trigger your internal smoke or fire alarm detection system. So that's the only warning you're going to get. So the short and simple answer is, look, to be quite honest, if you want to go down the route of providing something like that, yes, go on ahead. But my advice would be to look at your own domestic system to make sure your domestic system was up to speed. And if you felt the need that additional detectors were required, particularly close to whatever elevation is facing onto where the car is, then it might be worthwhile increasing the level of detection there. You could even mount an external detector that would be protected from the elements to a degree, but would allow you to sample air from the burning vehicle or from the vicinity of the car, and ultimately give you some sort of early warning. But again, it's cost and it's design. And then the ultimate question is, I said a moment ago about the circular economy, it's a case of not alone are you providing something, it's the cost of maintaining it.
Yeah, I was going to suggest myself that he buy a good fire retardant dog or something that would alert him, but somebody else come up with a better solution, a real engineering solution.
Well,
What
no,
about a
no,
longer lead?
no. Well, there's also, as the saying goes, there's also the low-tech solution, buy a bike. So
Yeah. Another question coming in here, Pat. In your opinion, will solar PV come and go as solar thermal panels have done in the last few years, as it seems the majority are only being installed to tick the renewable compliance box?
that's a very, very good question. That is a very,
that,
very good
yeah.
question. And the problem I have with that is the case of, it's a very, very good point, and I would agree. And trends come, trends go. But here's the rub: PV panels are not cheap. They're definitely not cheap. They're a significant cost and a significant investment. And if you're wondering, you're putting such an amount of money into a PV panel, and you could be putting that money into some other aspect of your home, whether it be the kitchen, the bathroom, which are always the two most expensive rooms in the house, or could be increasing the square meterage of the footprint of the building that you built based on the fact that you're not looking after the PV. I'd say no. It's a case of you may be looking at like any product. a PV panel has a certain design life, at which point it becomes spent or useless or whatever, or affected by the elements, etc. So there is going to be a point in time in the future. Most products have a 20-year design life. So it's a case of after 20 years plus in an aggressive environment, let's face it, they're on the roof. So it's a case of, depending on the damage, etc., they're going to have to be replaced at some point in time. So it's a case of, you're going to take off something that was current and top of the range this in 2021, in 20 years time, 2041. Yes, they could be obsolete, there could be an alternative out there, and you're going to be, of course, investing in that. Again, it's very, very difficult to say where we're going to be in 20 years time, but ultimately it's going to be a case of, personally, I can see the whole domestic energy production being massive in the next 10 years, where people will want to become more and more energy sustainable, based on the fact of what we're seeing at the moment, where energy costs internationally are soaring, gas prices are going up, electrical prices are going up. So it's a case of, a number of years ago, it was a case of, grow your own. Now it's going to be a case of generate your own.
Yeah, I agree. Yeah, and I think oftentimes there isn't enough attention, or even any attention on the embodied energy of these things. They sometimes completely ignore till somebody decides to do a final year project on it. Pat, I think the questions at this stage have come to a nice little end there, and I think without further ado, we might draw the evening to a close. And I'd like to thank you very much for the time you've put in. You and I know you've put in more than just tonight. There's been a few hit and miss periods over the last few days.
Oh, you better believe it.
You've taken to put the presentation together.